Alrighty, y'all. We're going to go ahead and get started. My name is Rylee. I'm on FRC 3481 BroncBots and also 4008 Atlas. I'm a senior this year. This is my 7th season with BroncBots. So I've done just a little bit and I'm a little bit involved. I've been our wiring lead for a couple of years now, and I'm also our FRC team captain, but I have been doing FTC since I was in middle school, and it's kind of where it all began for me.
Morning, everybody. My name is Dylan Watson. I am a mentor and alumni for the BroncBots, both FRC and FTC. I was the team captain of FRC BroncBots back in 2019, my senior year. I'm now a cybersecurity major studying at UTSA, the University of Texas San Antonio. A little bit about me, I was also the programming lead for a number of years and had a big hand in the wiring as well.
All right, so we're gonna go ahead and get started with the design process here. The design process is, it's crucial to having an effective robot. First, you want to figure out what you're trying to do. At the beginning of the season, that's just going to be what mechanisms you're going to need. You're going to do some research. That means looking at old seasons and old robots. That means seeing what teams who are doing kind of a robot in 2 days kind of challenge are doing. You're going to go ahead and brainstorm. Figure out what your different options are. You're going to prototype said options to determine what you guys think will be the most effective for your team. If you want to, you're going to complete a CAD. I think that this year especially, that's going to be especially important because with a CAD, that means that anyone on your team can work on anything because they have a full blueprint sitting right in front of them, which means that if your robot has to travel from one house to another in order to stay safe during this pandemic, everyone knows what's going on and what's where in the process. You're going to go ahead and you're going to manufacture whatever you've prototyped and CAD'd, and then you're going to test. And if it works, then that's great. And you might want to improve it, or you might want to work on improving something else, in which case you go back to the beginning, you brainstorm what you can do to improve, you prototype, you CAD, you manufacture, and you test. Very repetitive process. You'll see this all over the industry. This is something that you'll see all the way through engineering. I just want to jump into and go over a couple kind of basic designs that you'll see a lot. Common drivetrains, and you'll see other designs as well. In here, I just have kind of the general wheel types and kind of wheel configurations. So you see in the top left there an Omni-Wheel. Usually these come individually, but you are going to want to double stack them. Double stacking them just makes it so that at any point on the wheel, there's one of those smaller black wheels also. So usually if you're going to use an Omni-Wheel, you're going to double stack it. Mecanum wheels, which essentially allow you to go in any direction. They can be a little complicated to program and to design. We'll go over that a little bit more on their slide. And then sticky wheels, which are just your general cylindrical wheel. And then you can have a 4-wheel or a 6-wheel drivetrain. 6 wheels a lot less common for FTC, but you do see it occasionally. So Omni-Wheel Drive. You've got a couple different configurations for this. You have an X drive, which you see on the left. Kind of a little bit odd for programming. This one's a little bit older. You can see a lot of the old FTC electronics on there. If you are interested in this, my team has never done it. I would encourage you to do a lot of individual research on this and, and see how that works on your own. And then you'll notice I said that there's a 4-wheel drivetrain and a 5-wheel drivetrain. Or a 6-wheel drivetrain. For Omni-Wheels, you're going to have what's called a 5-wheel drivetrain. This is 4 wheels. You'll notice that the Omnis are not stacked here. I would recommend that you do stack them. But you'll notice that right in the middle between those two crossbars, you'll notice an individual wheel. What that individual wheel does is allow you to move side to side, and the rest of the wheels propel you forward and backwards like normal wheels. So that's what allows the omnidirectional on an Omni-Wheel Drive.
And with the X drive versus the 5-wheel, they end up achieving just about the same thing. You have full directional either strafing or going forward at the same time. I would say that the X wheel is probably more stable on the ground when it comes to point of contact on your robot. However, it is, as Rylee said, harder to program because you have to take into account all of the different vectors based on your joystick positions. Whereas the H drive is just a simple tank drive on the left and right, so forward and back. And then you could use like bumpers or buttons or something to go left and right at the same time. But at the end of the day, these two variations of the Omni-Wheel drivetrain end up accomplishing pretty much the same thing.
All right, we're gonna go ahead and move on to Mecanum Drive. Like I was saying earlier, Mecanums are a little bit more complicated solely because if you don't place your wheels the right way, nothing will work. You'll notice that simple Mecanum Drive right there. You want your wheels to kind of be in an X position. If you don't do it the right way, your Mecanum Drive will not work. Keep that in mind. You can find resources like this anywhere. Just Google FTC Mecanum Drivetrain. And there's all kinds of teams who have made tutorials on this stuff, but you do have to keep in mind that the more complicated, the more kind of effective that your drivetrain is, the more complicated it's going to be. So, your Mecanums have to be set up right, and programmer here, they're kind of difficult to program.
So they are difficult, but there's a lot because of how much Mecanums have really been gaining traction in the FTC community over the past, 3 years. I feel like maybe even 4, we've seen the Mecanum wheels really pop up as the prominent drivetrain. There's a lot of documentation out there when it comes to programming. One of the things I do want to say about them is what Mecanum wheels allow for is you can use you can allow your robot to basically be a normal tank drive, but then depending on how you rotate the wheels, it can move in any given direction. And if you know how to do some fancy vector math, you can make it go any speed at any angle that you desire based on your joystick input. The other interesting thing about them is that, so one of the pitfalls of, Rylee, could we go back a slide, actually, back to the Omni wheels? So if you look at the right here, one of the pitfalls of the 5-wheel, something that Rylee and I have both experienced when we first started FTC, is that if the weight distribution on your robot is such where it either pushes the middle down too far because most of your weight is in the middle, or all of your weight is on the edges, and so it pushes your edges down, your middle wheel won't have enough either torque or traction to propel your robot sideways. With the Mecanum wheels, however, because it's all the same wheels that are being used to drive the robot, so if we go back to Mecanum wheels now, what you'll notice is that traction is not usually a problem. So Mecanum wheels, like I said, have become pretty much the dominant wheels in FTC recently. And because, unlike FRC, contact isn't really an issue in FTC, you're not hitting each other, then it's not a problem of being pushed around or anything. So my personal recommendation, Mecanum wheels.
Mecanum wheels, for sure. Just keep in mind that you do need to do a certain amount of research at the beginning to make sure that you design it effectively to where it's going to work, and also that your programmers acknowledge that they are going to need to do quite a bit of research in order to learn how to program these.
Just a quick reminder for those who joined us just a moment ago, we're asking that everybody keep your camera and video off for the presentation. That way we can have it run smoothly.
Awesome. So I did not go over a sticky wheel drive because you haven't really seen them too much in FTC, but the one that you see on the left here is, again, you can find a lot of these resources just by Googling it. But you'll notice that that's actually, that's a sticky wheel drivetrain on your left. These are frame types. On the left here, you've got a square frame, can be a rectangle. It's just a pretty general type of drivetrain. You'll see these a lot. And then on the right, you have an H frame, also very common. Every once in a while, you'll see an H frame with only one bar in the middle. I do not recommend this, especially if you're going to have any amount of weight on that middle bar. It will begin to sag if it's the only one there and it has a significant amount of weight on it. So just keep that in mind when you're designing your drivetrain. I wanted to go ahead and move on to shooters. For kind of a couple general shooter designs, I personally have used this design before, and it's pretty awesome, but it also has some problems. This is a flipper design. So as you'll notice, it's a flat kind of piece of Lexan. Occasionally it'll be metal, but it's usually Lexan or plexiglass. And what you're gonna do is you're gonna make some kind of bar that it will engage with, and it'll flip up. It's really awesome sometimes. Every once in a while, you're going to need to replace your Lexan, because at the attachment point at the base there, it will start to crack. Every once in a while, it will break off completely. And also, as it bends over time, it's going to become more and more flexible, which means that while you may calibrate it in your shop to be very accurate, by the time it's the end of the competition, it will not necessarily be that accurate. Just something to keep in mind, because this is the kind of thing that will need to be calibrated all the time, because it's constantly going to be changing.
Now, one of the things that I can say is, so I don't know if anybody here remembers Velocity Vortex, but Rylee and I were both on, I think she was on our middle school team during Velocity Vortex, and then I was on one of our high school teams. And something that we noticed, because we used a flipper shooter during Velocity Vortex, is it's very good for very light air-filled balls, such as the wiffle ball, which is why it was so prevalent that year.
And
however,
also large goals.
and also, yeah, very large goals. So if you don't need it to be extremely accurate, I also agree with everything she said about calibration. What you'll notice about the other wheels we go over in here is that if you do CAD, if you do computer-aided design, which we're going to go over in a little while, and you do some physics on your shooter, typically you can tell where your ball is going to end up. That physics is not going to be nearly as accurate on this type of shooter. So you have to be ready to do a lot of calibration and testing manually and knowing what you need to do. It worked out pretty well for us that year, but I would say that if you have a small goal or a heavier or more dense ball, then this is not the shooter to go with. But if you just need to chuck a wiffle ball through the air, then that's the move.
Just keep in mind that for Velocity Vortex, the goal that we were shooting into was the size of one of those huge yoga balls. So accuracy-wise, we had like a good foot on either side of the center of the goal to mess with. So this shooter is definitely not what you want to go for if you're going for accuracy. The next thing that I want to go over is a flywheel. You'll notice two different types here. Both of these are FRC, but they could 100% be made smaller for an FTC game. You'll notice a one-wheel flywheel that just kind of it intakes and shoots that way, or a two-wheel that's going to shoot like this. Both of these are going to be really awesome. I personally have used these in both FTC and FRC, but there's a couple things with this. One, they're a little bit more complicated to design, especially if you're going to go with the one-wheel design. You have to get the right game piece compression in order to use this, or it just won't work out. They're a lot more accurate. You can mess with your speed. You can use encoders on your motors and figure out exactly what speed you need to do in order to go a certain distance. But again, you will need to mess with this for accuracy, because it will not necessarily be accurate right when you've started. So it's going to need a lot of manual work, and they're a lot more complicated to design.
Now, I can say that another thing that these flywheels are useful for, specifically the two-wheel version that you see on the bottom there, we typically call that a baseball shooter, because occasionally when you're playing baseball and you use one of those pitching machines, that's what you'll use. No, I'm not. And so that is different from the big flywheel. We noticed this in FRC this year, because the big flywheel can have what's called backspin on a ball, which can kind of make it wobble in the air a little bit. Sometimes you want backspin. I encourage you all to go read about the physics of backspin, if this year is a shooting game. If it's not, then oh well. And then the smaller one, not the smaller one, the baseball shooter can make it a lot more streamlined in the air, can also be used to shoot different types of objects, whereas the flywheel is typically better for the balls.
Right. So go ahead and move on. This is a catapult. I personally don't necessarily recommend using a catapult. We have not found success with these in the past, but if that's something that you guys want to prototype and try out, that is a-okay with us. I will say that they are not necessarily very accurate, but it does depend on how you design them, and they tend to take up a large portion of the robot just because it's going to be a very large mechanism, and you're probably going to need some kind of spring or other mechanism similar to that in order to help your catapult swing forward a lot faster, because just putting it on a motor is not necessarily going to be enough. I would recommend that you do a lot of research on this. Again, this is something that our team has prototyped and then thrown out because we don't necessarily like the design. But if it's something that you guys want to make work, go ahead and do your research. There's all kinds of resources online that you can access. And you can find all kinds of stuff about this.
And I have to say, so I think a lot of both of us, but especially me, my design expertise mainly comes from the FRC side of things. But one thing I can say is that I have seen, specifically on the FRC side, catapults used effectively. So I can tell you that they do work. Don't throw them out immediately.
Right.
Our team has not found success with them, but I have seen them been used successfully.
But a lot of the success that we've seen with catapults has been with FRC, which is a much larger area to work with. Correct. And a lot more powerful materials and mechanisms. So just keep that in mind.
As you will.
All right, we're gonna go over intakes now. So I'm just gonna go over kind of the general types. You've got kind of your loose flimsy material attached to a couple stages of PVC pipe or an axle or something. These are really easy and cheap to design and build. As you'll notice, these are like PVC pipe or axles. Sorry. With surgical tubing or zip ties attached. They're very versatile. They can work on multiple kind of levels. You'll notice that both of these are kind of 2 levels high, meaning that they can intake the ball from the ground and move it up to the top to your ball storage or game piece storage. They're usually pretty cheap, but there are a couple kind of pitfalls with this. One, your zip ties or surgical tubing, depending on how you attach it, may inevitably move, break off. I have seen a lot of intakes like this trap game pieces, which is just not fun. You have to, again, everything that you're going to build is going to need a lot of testing and work and reiterating in order for it to be good and functional. I have seen intakes like this be used very well by teams like MacBots. 9829 MacBots, I'm sure a lot of you guys know them. So just keep in mind that while it might be easy and it might look like it's going to work really well, you're still going to need to test it in order for it to be super functional.
And on a personal note, we seem to have found that surgical tubing usually works a little bit better than zip ties.
Yes.
Sometimes we will add zip ties in between surgical tubing in a pinch where we need a little bit more oomph to rake the ball in, but usually surgical tubing or some other type of rubber. So you can see in that bottom picture there, that's what surgical tubing is kind of your best bet as far as we have found.
There's also different kinds of surgical tubing. Some of it's thicker. Surgical tubing is going to be kind of a cylinder, and it usually has kind of a cutout in the middle. Some of them have smaller or bigger holes in the middle. Some of them are more dense in that they stay a lot more straight than others. And some are going to be like that particular one looks like it's pretty wiggly. So it depends on what kind of game piece you're intaking. So just keep that in mind because it's going to all depend on the kind of game piece. I encourage you guys to drop into our strategy session later today because we'll probably be going over stuff like this and potential like ideal mechanisms.
Based on the game that gets revealed.
The game that's revealed.
Yeah.
Another one, this is a conveyor belt. There's a couple things with this. The last one that you saw was vertical in that you can intake something and lift it up on your robot and over. I'm going to tell you right here, right now, conveyor belts usually do not work vertically. They're more of a horizontal mechanism. They can move things horizontally on your robot or on an incline, maybe, but I really don't recommend it. I really recommend that if you're going to use a conveyor belt, it stays horizontal or at a downward incline because they don't work so well. So looking at the two belts, inside your two belts, you have two basically big white plastic sprockets. They can and will slip, especially if you don't have your stuff tensioned right. And also, almost every time that we've ever used these, they've need additional traction. So I'm sorry. You'll notice on the bottom conveyor belt right there, little kind of gray rubber inserts. I think you can purchase those with the conveyor belt, and they're basically just small little rubber pieces that you can slide into your conveyor belt, and they basically just create traction and make it easier for your conveyor belt to grip onto something. They're also usually very slow. This particular one, you'll notice, is an intake onto a conveyor, or a flywheel intake onto a conveyor belt. That's usually how these work because the conveyor belt can't necessarily intake anything itself off the ground. This one is, I call it a flywheel on the last one. It's also a double wheel. This particularly is good for kind of cubes, anything that's flat on the sides, but it can also be used for balls or oddly shaped game pieces. The one on the far right here, you'll notice, is just two compliant wheels. The one next to it on the left is a couple of different compliant wheels and also a couple of sticky grippy wheels. It depends on what you're going for. Compliant wheels are very good for this kind of thing. You can get additional grip, which basically means that the space in between your two wheels can actually be smaller than the actual width of the game piece because your wheels are actually going to compress. But you have to keep in mind that if you have too much compression, you're going to overwork your motors. We personally really like these, especially for FRC. Like in 2018, we had cubes as the game pieces. This is the kind of intake and also the kind of outtake that was used. Do a lot of research on these. These are everywhere. They're really common. They're really useful. They're really successful. So I would just focus really hard on these and use these to your advantage because these work really well. This is a paint roller on an axle. These are cheap. They're simple. I took this from a YouTube video. You would kind of 3D print a cap that slides into your paint roller that goes onto your axle. It depends on the game piece. I wouldn't necessarily recommend it, but I have seen it before. I have seen it be used successfully, not necessarily with a paint roller, but with like a foam roller or a piece of PVC pipe that has some kind of like grip tape on it or something like that. This is just the one that I found. There's a couple things with this. One, unless you have it on a variable height mechanism, a whole separate mechanism, it is going to have one set height. Which means that if there's any chance that your game pieces can vary in height, that could be a problem. Also, this is just one piece. You might need additional assistance with something like the PVC pipe zip tie surgical tubing intake to move it up to your game storage if your game storage is at the top, or the conveyor belt to move it to the back of your robot or whatever. But I will say that these are usually pretty resistant. They don't break very easily. And also that they're pretty cheap and simple to manufacture. So we're gonna go over kind of lifts and climbers now. There's a couple different kinds of each of these. You'll see them made a couple different ways on these. So a cascading linear slide, and you'll notice on the bottom left one, you've got a rack and pinion kind of mechanism, but on the top right, you've just got different kinds of rigging. And then the left is just kind of a real life example as opposed to diagrams. These can be rigged continuously or they can cascade. I recommend that you go ahead and do your own research on what each of those mean, because they do mean different things and they will work differently, and some are better than others in certain ways. You can either have a gravitational or powered pull down. I would recommend powered. When you start to rely on gravity, you start to get a little wiggly and wobbly, and stuff will just get stuck and then drop. Whereas if you have a powered pull down, it's usually going to be a lot more smooth. You can get pretty much to any height using just one motor. I don't necessarily recommend that you use just one motor, especially if you're going to use that one motor to lift up several different pieces of linear slide, but do your research on that. And these are very powerful. You'll see these a lot. We were talking about velocity vortex earlier. I saw a lot of these being used to lift up those huge yoga balls and placed in the top of the goal. These are really awesome, but there are some pitfalls. A lot of times we've done it, I've seen other teams do it, they're doing great the entire match, and then all of a sudden their string comes off their lift and they're done. That's it. Their lift doesn't work anymore. None of it.
Right.
Even if one of your strings slipped and it's in the wrong place or it gets cut or whatever. And it can also be very difficult to rig it the right way. If you make one mistake in your rigging, you could potentially mess up the entire thing, especially if you're doing like a cascade rig. So it's very particular, and it does tend to slip a lot.
Now, a lot of people on a cascade have the inclination to use a thick rope because they feel that either it'll be more sturdy or it'll stay in place better, and then big pulleys. And actually, in my experience, what I would recommend is a very thin fishing or steel wire, something that you can look up the rating on for pounds that it can hold, and that it's get something, you know, you can get it at you can get it off Amazon or your local Bass Pro if you're doing a fishing line, something, but something thin, and then use small pulleys. And what that does is that will allow for your rope to have a lot more space in between each track. So if you look at the one picture, not the diagrams, but the one picture, you can see the small pulleys with the rope, and those ropes, you don't have to worry about them hitting each other or whacking into each other and knocking each other off of the pulleys. If you're using a really thick rope, it's more likely to jump off, in my experience. Use a deep small pulley and a thin rope with a lot of pull. It'll look more aesthetically pleasing, and it'll go a lot easier. There'll be a lot less slack in the rope, things like that.
The other thing with that is that one method that I know our team has used a lot when we have pulleys is putting a spacer, a large spacer on either side of the pulley. That basically makes it so that, you know, your string has to jump a good ½ inch before it can actually remove itself from the pulley. It's especially useful because a lot of times as your string goes up, it might stretch a little bit. So when you bring it back down, your string is going to be really loose, and it's going to make it a lot more difficult for your strings to stay on. So putting a pretty big spacer on either side of your pulley makes it so that your string can't jump as easily. So that is your kind of linear slider cascading. This is a scissor lift. Not something that we have ever used. We've definitely prototyped it. We definitely have one in our shop that we play with a lot, but they tend to be very heavy. They're very sturdy. They're usually pretty reliable. It's all metal, so you don't have to worry about any kind of cable or rope. They can get pretty high and they're driven by a couple motors, but again, they're very heavy. And as you can see in these pictures, they take up a lot of space. You're gonna want a good portion of your robot to just be dedicated to a scissor lift if you're going to do a scissor lift.
Now, one thing I can say is they take up a lot of horizontal space, but they leave a hole in the center.
Or you can do something like the bottom one where it's a couple inches apart.
and they don't take up as much vertical space as a cascading lift. So with a cascading lift, if you need to get, you know, a certain amount of height in the air, it'll be, you know, a certain height tall when it's compressed, because you're only as small as your biggest individual stage. With the scissor lift, it can sit a lot more compact.
Right. The way that that a cascading one works. Oh, sorry, my dogs are up here, y'all. The way that the linear slide works is that you need a certain number of stages. So if you need to get a certain height up, you're going to need maybe 3, 4, 5, even 6 individual linear slides in order to get to that height. With a scissor lift, it compresses down. So even if you have to add an additional bar or two at the top, it's really only going to be an additional inch or two. So that's pretty cool. This is a rotary lift. Not necessarily something that you see very often in FTC, definitely more of an FRC kind of mechanism, but they're really useful for a limited height. They're usually driven off of 1 or 2 motors, and they're chained up. You can see that kind of right here. Let me go ahead and annotate so that you guys can see that. Oh, can I annotate?
Doesn't look like it. Let's go without it.
You'll notice, oops. See, this is why we don't listen to me. On this picture right here, you'll notice the chain on the top right picture. That's kind of your mechanism right there. That's chained down to a motor, and it basically just lifts up your entire kind of bar. These can be used to score or to climb, but these take up, when I say that these take up the entirety of your robot, they pretty much take up the entirety of your robot, because they are going to settle into a triangle shape when they're down. And when they come up, they're going to be tall, but there's really no space anywhere on your robot usually to put anything else. Your intake is probably going to be attached to your lift. Your storage will be on your lift. So it's all going to be right there.
With that said, one of the things about the rotary and about this 4-bar we're about to talk about, but specifically the rotary is very useful for lifting heavy objects because it can be chained up so much. We have had in the past really good success with using it for heavy objects. Now, if you know anything about physics and about how torque works, you will need a lot more force because you're driving it from the pivot point, and your object is typically held out at the end. The further out your object is, the more your force needed compounds. But with this one, you have the opportunity for some crazy high gearing and crazy high torque if you need it. Whereas with the Cascade, you can also achieve that using like a gearbox or something, but in FTC where custom gearboxes are less common, it can be more difficult to accomplish that.
Okay. Sorry about my dogs. They're like being really in the way. Okay, so now I want to go over a 4-bar. It's very similar to the rotary lift that you just saw, just kind of a slightly different mechanism. You'll notice that it's 4 individual bars. You've got 2 kind of horizontal that get angled as you move, and 2 vertical bars, hence why it's a 4-bar lift. These guys are highly reliable. We use these, we've used these several times for a middle school team as kind of like a training mechanism. It allows for a lot of vertical kind of motion. It'll go up pretty high, and it's usually driven by 1 or 2 motors. But again, these take up a lot of space, the vast majority of your robot. And you're not necessarily going to have a lot of space. And again, the farther stuff is forward on your robot, on the end of that bar, the more force you're going to need to lift it up. So just keep that in mind. Very similar to the last. So I'm going to take the last kind of probably 5 to 10 minutes here to go ahead and go over CAD. I will be CADing in Solidworks because our team is sponsored by Solidworks. If you're interested in getting sponsored by Solidworks, they sponsor first teams. That's the QR code and the link to go find that sponsorship. They'll give you a certain number of free educational licenses that you can distribute to your team members. We really love Solidworks. I'll give you guys another second or 2 to scan this. And then I'll go ahead and jump into the basics of CAD in SolidWorks.
The cool thing about SolidWorks, so a couple things is, and this first part I'm going to preface with do your own research on this, because I don't want you to take my word for it and then be let down. But I have been told that SolidWorks will sponsor most, if not all, teams that apply to this. So it's not like one of those things where you are, you know, trying really hard to get this license and then maybe you get it, maybe you don't. Chances are, from what I've been told at least, chances are this sponsorship will be given. If you apply, you'll get, I know we get a certain amount of free licenses. I don't know.
45 free licenses every year.
Whether or not that's standardized across teams or if it's based on your number of members, I'm not sure. The other cool thing about SolidWorks is, so the two main CAD softwares that I see is SolidWorks and Autodesk Inventor. Those are both industry standard CAD programs. SolidWorks is a little bit more expensive, which is why we get the licenses for free as a sponsorship. But they're industry standards. So if you come out of high school, go into college, and then even come out of college, or if you go straight into the workforce after high school knowing SolidWorks and you want to get into engineering or maintenance tech or anything like that,
big advantage.
SolidWorks is a huge leg up, as opposed to something like Onshape or Tinkercad, which may be helpful and do what you need to do for FTC, but you are really gaining those industry CAD skills by using something like SolidWorks or Inventor.
Yes.
Which are very similar. We just happen to be using SolidWorks.
Does anybody else need to scan this? Please go ahead and throw in the chat if you still need to scan it, or else I'm gonna go ahead and hop into SolidWorks. Nope. Alrighty. So let me go ahead and exit out here and go ahead and share SolidWorks. Okay, so this is the SolidWorks kind of home screen. I'm gonna go ahead and throw this on my other monitor. Okay, so can everybody see?
Rylee, go ahead and, oh, there you go.
Okay.
I think that should work.
This is the SolidWorks homepage. You'll notice over here you've got a couple small tabs, but we're going to go ahead and work on the top here. This is your home page, a new and an open. I'm just going to go ahead and start a new thing. You're going to have,
grab it by the top there. Yeah, there we go.
Okay, so you've got three options here. You've got a part, an assembly, and a drawing. We personally don't use drawings. We will make the part individually and then turn it into a drawing. So that's how I recommend that you do it. But again, if it works for your team, if you've done your own research and figured it out, do whatever you want to do. I'm just going to go ahead and make a new part.
Drawings are typically used in industry for engineering reports and printing out and showing what you have created in different views from different viewpoints. With that said, yeah, we haven't found a huge use for drawings inside of our
the only reason that we use them is if we're making a flat part. If we want to cut something out on a bandsaw or something like that, that's going to be kind of an odd shape, we'll make it into a drawing and then print that out and actually glue that down to the metal or Lexan that we're cutting in order, basically just to make a guide. So, okay, this is what your blank application is going to look like. You can use extruded or revolved boss base. We haven't used revolved a whole lot. We pretty much exclusively use extruded. So I'm going to go ahead and make an extruded boss base up at the top corner here. And I'm just going to select the plane that I want to work on. I'm going to work on my front plane, but you can pick whatever plane is going to work best in your assembly. And I am going to make a piece of PVC pipe. So basically,
so really quick there, a little bit on the planes. If you are, basically the planes just represent which orientation you're looking at the piece from. So for example, if you're building it as if you were looking at the front of it, then work on the front plane. The top and the right also go accordingly. If you're building it as if you were looking down on it, build on the top plane. If you do that for all of your pieces will be really standardized and easy to look at. I know.
When you drop it into an assembly, it'll be a lot easier.
Yeah.
So, okay, you'll notice that I selected the circle over here. There's also a rectangle. There's different kinds of circles that you can make and different kinds of rectangles that you can make. You mess with those settings and decide what you like best. Then I'm going to use this Smart Dimension tool. What this Smart Dimension tool does is that when you're inside of a sketch similar to this one where I'm making a part, you can select something and actually decide what dimension you want it to be. So right now I'm affecting the diameter of the piece. If I want it to be a 5-inch diameter, it's now a 5-inch diameter. I can do the same thing with radius. I can decide where I want it on the plane. If I want it on the center of the plane, I can make it on the center of the plane. So there's that. Now I'm going to go ahead and exit my sketch. With this button on the top here, and it's going to ask me how much I want it to be extruded. So right now it's 0.1 inches long. That's a little short for a piece of PVC pipe, so I'm going to make it 5 inches long. And now I have a 5-inch diameter, 5-inch long cylinder, and I'm going to go ahead and press my check mark. So I now have this piece. It is solid. It's basically, think of it as like a solid piece of metal right now. But I want a piece of PVC pipe. So what I'm going to do is go to this extruded cut button right here. This extruded cut button is going to allow me to cut something out from the middle. So think of it kind of like drilling a hole. I'm going to select it asks for the plane that you want to make your hole on. So I want to make my hole on the same end as the flat end of the cylinder. So I'm going to select that plane. And it's now got me in another sketch. So I'm gonna go ahead and make another circle. It doesn't matter where I put it. And I'm going to, I can click on both circles, and you'll notice that it kind of gives me an option to decide how far apart they are. So now they're exactly centered on one another, but you'll notice that the middle of my PVC pipe is actually bigger than the outside of my PVC pipe, and that's not gonna work. So if I made my PVC pipe a 5-inch diameter, I'm going to make this a 4.8-inch diameter, and that makes it ever so slightly smaller. So I'm going to go ahead and press my check mark. I'm going to exit out of the sketch, and you'll notice that it usually sets it to the same length as the current part you're working on. So I'm going to go ahead and press a check mark, and I have a hollow cylinder or a piece of PVC pipe. How to make a custom piece, it's pretty simple. So there you go, that's a custom piece. I'm now gonna go ahead and save this. I'm just gonna save it to my desktop. We, as a team, use a software called CAD, which basically, if anyone knows what GitHub is for programming, it's very similar, it's a similar concept. Essentially, you have your CAD team all in this one kind of folder, and someone can upload whatever parts they've worked on, they've downloaded, and then everyone else can download them so that everyone has access to all of the pieces. That way, when you have one overall robot CAD, when someone makes a change, you push the change and everyone else can pull down the change, and everyone can see what's going on. So I am now going to go ahead, you see this little white piece of paper, that's the new button. I'm going to make an assembly, and I'm just going to show you guys how you would add multiple pieces in together. We have about 5 minutes left. If anyone has questions, I can take a pause on this and go ahead and answer questions. Please feel free to throw any questions in the chat. I'll keep working on this, but if anyone has questions, please put them in the chat and we'll answer them. So in begin assembly, you start an assembly with one piece. I have this piece. I just selected it, and then I'm going to place it. So now you'll notice that I have this one individual piece. I am now going to insert a second piece because you can't have an assembly, a robot assembly, with only one piece. And I'm actually just going to insert the same piece just to give you an idea of how this is going to work. So I'm going to insert my second piece. It might look lined up. It's definitely not. That's okay. In order to join multiple things together, you're going to use what's called a mate function. It's right here. It looks like a little paper clip. And your mate function is going to conjoin two things. So if I want to mate together my two cylinders, I'm going to select those two faces of my cylinder, and my cylinders are now together on that face. They can still move around and everything, but you'll notice that from every angle, it's flat. Do you have a question?
Yes, so I have a couple of questions really quick. The first is, how do we download? I think, Aiden, you're talking about how do you download the software, Solidworks. we talked about earlier, so SolidWorks is quite an expensive software. It's somewhere between $600 and $1,000.
Per license.
Per license. But like I said, your FTC team can get sponsored by SolidWorks to get a certain number. So we get 40 free licenses. Once you have applied to that, and that link is in here, or you can just Google SolidWorks robotics sponsorship. But that link is also in the presentation, which we will be posting online. Talk to your coaches about where that'll be, but it will be on the BronkBots website. You can click on that link and go to the SolidWorks application. I also have a question about where do you find CAD downloads for GoBuilda? So, Rylee, you don't have to stop screen sharing or anything. I'm just going to say on each individual website. So, for example, if you take a Rev part, you want to take a look at it? Okay. If you have a Rev part or a GoBuilda part or a Vex part, those CAD downloads will be on the manufacturer's website. So I know for a fact that GoBuilda has CAD downloads for some of their pieces. For example, if we go to GoBuilda really quickly.
I'm going to go to Rev.
You're going to go to Rev?
So if I'm on the Rev website.
Just go to a product like the gear. Go to that gear down there.
There's a gear?
Yep, right there, the pinion gear.
So here's the pinion gear. If you scroll down, you're going to look at, there's usually some kind of CAD. The thing with CADs that you download is that usually they're in step files. SolidWorks does not work in step files. SolidWorks works in solid parts, SLDPRT. So you're going to want to individually open the part. So I'll show you. If I press, it's downloading, I go to my SolidWorks and I'm going to press the open button up here. Oh gosh, I'm not sharing that. Share, here we go. Okay, so I'm in SolidWorks. I'm going to press this little open folder button right up here. I'm going to open that, and when I go to downloads, you'll see that part that I just downloaded. You'll notice that it takes it a second to convert it.
It's thinking about it.
There it goes. So you're going to run import diagnostics. You can, or you don't have to. It doesn't really matter. Now that I have this part, you're going to have to save it as a solid part, and now you can use it in your assembly. Sometimes when you use step files as opposed to solid parts, SolidWorks doesn't really like it and gets really upset.
Step is, however, the universal CAD thing, CAD part. Now, I can tell you specifically because you asked about GoBuilda, on my other computer here, I'm already on GoBuilda's website. They have the same thing. If you go to one of their parts and you go to the download section, so yeah, just go to
steel grid plate.
Yeah, and then go there. The download section right there, it says step file. That is your CAD file. You can download that directly from their website.
If you can't necessarily find a part, there is stuff. So GrabCAD actually has a website. So if you Google a part and you can't find the step file for it, sometimes other teams will have CAD'd it individually and then uploaded it and shared it on platforms like GrabCAD that anyone can download and use in their CAD.
Additionally, someone asked if there's a repo with all of the FTC parts. So I know that FRC Team Spectrum out of Houston, they have a repo, but I think that's mostly FRC parts. I could be wrong. So as far as Tetrix and GoBuilda parts go, really, I think you are best off going to look at their website for the specific part you need. I know that's how my team operates. Rylee, I am going to give you a time check. We're at 9:50, so we need to wrap this up.
I would recommend personally, what our team does is we have a very large repo. You'll notice that there's a common folder right here. While this is majority CAD stuff, there is FTC stuff, or while this is majority FRC, there is FTC stuff in here. I would make your own personal team repo, and then you can share that out however you want to, but I would keep your own personal one and just build it up as you need stuff. Just add stuff into your comment as you use it.
Now, Rylee, can we put up the slide for not resources, but the contact us? So there is a lot more to CAD than we talked about today, and a lot more to design, but there's a lot of information that you can't exactly cram into an hour. So one thing I am going to tell you is that Rylee and I give a number of CAD workshops every year. They all look pretty much like this, but if you're wanting a more in-depth and hands-on thing where you can actually walk through it with us, because practice is the only way to get good at this, we are more than happy to sit down with you and your team on a call privately at some point and actually go over the ins and outs of it, and maybe we'll walk through CADing a drivetrain with you or something.
So yeah, this is our resources page. We have all kinds of FTC and FRC resources on this website. If there's something that you don't see that you want, please let us know. Please save this. You guys are more than welcome to use these resources anytime. And also, here's our contact us page. You guys are more than welcome to send us an email. We're more than happy to work with you guys individually. So yeah, please feel free.
Awesome. And we will see you all. So next up, we have the wiring presentation at 10. There's a couple other presentations going on at 10. Let me read those off to you guys real quick. So if you go look at the schedule, on the first column, so the first session, there's going to be intermediate programming given by my friend Zane from the Bronkbots. Here, we will be giving a wiring and control system presentation. And then over on the third stream, Mr. McChesney, who is an expert, he's FTA for the World Championship, will be giving a on-bot Java and blocks programming presentation. So we look forward to seeing everybody at 10:30. We're going to continue to monitor the chat and the waiting room, but we're going to have our mic and camera off as we prepare for our next session. Thank you guys so much.